So for this chapter, we're mainly going to be talking about the periodic table and trends across it. We separate the periodic table into groups and periods. Groups are also called families and are like the columns of the periodic table. Periods are they're sort of arbitrary, but they are important later, I do think, and they are the rows of the periodic table. Bad line, sorry. We give names to all of these groups, but for our chemistry class, we only care about a few of the names. Group 1 we call the alkali metals. Group 2 we call the alkaline earth metals. Group 17 or 7A we call the halogens, and Group 8 we call the noble gases. Seeing their positions on this, it's a little weird to, it's a little unintuitive, but like over here they have one extra electron, so we say that they have a +1 charge. So every single group, every single element here has a +1 charge. Every element in the alkaline earth metals has a +2 charge. Every element here has a +3 charge. Uh, Elements here are a little iffy, and we don't touch them too much for ionic bonds, so we don't care too much about their charges. Elements here have a -3 charge. Elements here have a -2 charge, and elements here have a -1 charge. You might have seen that I conveniently skipped this entire block of elements, and this is because these are the transition metals. They have weird properties, but for this class we're going to say that they can have any number of charges as long as they're positive. So again, earlier at the video I said that there would be certain trends here, and this is like pretty important for this class at least. So for the atomic radius, it is half the distance between neighboring atoms, because like usually you aren't gonna have atoms right, but like just by themselves. The ionic radius is which is difference the the neutral thing with like blank electrons, or like with the same amount of electrons as the number of protons, and the between like sorry, which is bigger, which is larger, like the size differential between the neutral thing where the electron amount and the proton amount is the same, and which is bigger between like the ion, which is back to like this here. This has like one extra proton or one extra electron than it would have a proton. So it's just saying which is bigger there. Electronegativity is what we is for us. It's the ability to gain an electron. So this is, and again, all these trends have a certain trend, I guess you could say, across the periodic table. Ionization energy is opposite of electronegativity, where it's the energy required to remove an electron. We kind of measure ionization energy weirdly, in the way that it's kind of like the opposite of what you would expect. So for atomic radius, when we go down the periodic table, and to the, it has a higher radius, and when we go to the right, it has a smaller radius. For ionic radiuses, the ions are smaller, and for anions, the ion is bigger. For electronegativity, when we go up, the electronegativity gets higher, and when we go right, the electronegativity gets higher. For the ionization energy, when we go up, ionization gets higher as well, and to the right, energy gets higher as well. This is really stupid, I think. I think ionization is really dumb in the sense that it's very unintuitive how it's like the opposite of how you think it would be like measured.